Hey guys, today I'm going to be starting a series where I'll be explaining computer science and Boolean logic in Yeeps VR. So let's get started. In today's episode, I'm going to be going over logic gates and possibly getting into binary. To start off, this is a button and a wire. A wire has an input and an output, and it sends a signal to a component. For example, when I press this button, the screen turns on. The screen is the component. The wire sends the signal, and the button creates the signal. What Boolean algebra does, and logic gates basically, is that it will change the function of the wire, and it'll change how the wire works, how it receives signals, and how it outputs signals. The most basic logic gate is the NOT gate, which, as you can see here, you might notice that the screen is always on. The thing that the NOT gate does is it will turn off once it receives a signal, basically doing the opposite of what it's told. This is when it starts to get a little bit more complicated. What we have here is two wires going into an OR gate. What the OR gate does is it will take two signals and basically string them together so that if one is on, the screen turns on. If the other is on, the screen turns on. Another important thing to note about the OR, and which we'll go over this later, is that it will still be on if it receives two signals. This is the AND gate. If I turn one wire on, it does nothing, and the same with the other wire. However, if I turn both wires on, then it outputs a signal. This is one of the most important gates in computer science, which we'll see later in the series when we build like big things like calculators and such. This gate is a little bit more complicated. It's called the XOR gate, or the exclusive OR gate. Now, what's different from this than the OR gate is that it does take one signal, but the thing is that it doesn't take both signals. You can see if I turn both on, it turns off. Now, obviously, I can't get them at the exact same time, so, you saw it turn on a little bit. But if both of the signals were to happen at the exact same time, then it would not turn on. Now, this is a little bit more targeted towards Yeeps. If you're using this to learn more about Yeeps wiring, then this right here is the toggle. You can see when you press the button, it turns on. Now, the thing about a toggle is that obviously you can see it's staying on and it's not turning off. You can either turn it off with this button, or you can turn it off with this button. Now, if you're playing Yeeps, then that signal will be on the side in this little red input thingy. Now, the thing about gates is that usually in builds, you don't just use one gate. Obviously, you string a lot of gates together, and it creates, like, complex circuits. Another thing with gates is that you can invert the signals with the NOT block. And usually, in computer science, people just, put, like, an N before the name of the gate. So, for example, you would have, instead of AND, it would be NAND. Instead of OR, it would be NOR. And instead of XOR, it would be XNOR. Oh, and by the way, this is just for Yeeps, because I see a lot of people mixing this up. When you're wiring, make sure you know that this is the output, and this is the input. You're going to notice that this part extrudes, and this part intrudes. If it intrudes, it's an input. If it extrudes, then it's an output. Binary is a number system, kind of like the one that we use, except because it only has on and off buttons, numbers can only be represented with two digits, 1 and 0. Now, how this is used in computer science is with wires being on and off. An on signal would be a 1, and an off signal is a 0. The number system that we use in real life is called base 10, and it's called base 10 because we have 10 digits, 0 through 9. You may recognize hearing like ones place, tens place, hundreds place, and so on and so forth. What you may notice about those is that each time it multiplies by 10. How binary works, since you only have two digits, is each space you multiply by 2. So for example, would be the ones place, this is the twos place, this is the fours place, and this is the eighth place. You may recognize binary from things like the Matrix, where they had those big ones and zeros on the screen, but that actually means something. So remember how I said that on represents a 1 and off represents a 0? Well, now let's actually make numbers with it. So if I were to make the number 5, it would be 0, 1, 0, 1. Like this. This is off, so it's a 0. This is on, so it's a 1. This is off, so it's a 0. And this is on, so it's a 1. Now, like I said, 1's place, 2's place, 4's place, 8th place. So this number represents 5 because you have a signal in the 1's place and the 4's place. Put 1 and 4 together, you get 5. Binary is used for a lot of things in computer science. It's how calculators are made. And you can add numbers together with binary, you can multiply numbers with binary, and it just gets really complicated, which we'll get into later in the series. For now, let's make a combinational lock code. A simple circuit, but still pretty cool. If you're using the series to make something cool in Yeeps, then a combinational lock code should look something like this. But we're not here to just copy build, so I'm gonna explain how it works. Now these 4 buttons are all hooked up to toggles. This is how you select. Now, like most circuits, this one uses binary, and it'll compare it to a predetermined code. And if it's right, it'll open up this door right here. Now, how it actually works is, with the code, you'll just put NOT gates for zeros and wires for ones. So you can see, since my code was 1010, I have wire, NOT, wire, NOT. And all of them are going into these AND gates, so that all of the AND gates need to be powered by the previous AND gate and this wire next to the thing. Alright, so you can see when I put in the right code, when I put in one of the wrong numbers, it turns off. Because this NOT gate turns off, and this AND gate is turned off because this is. And that prevents all of these other AND gates from turning on. That's how that works. That was a lot in one video, so let's just do a little review. We learned how the binary number system works, and we also learned how to string Boolean functions together to make a lock code, which is pretty cool, honestly. So stay tuned for the next videos so you can learn more complex circuits.